Hello, geometry students. This is Miss Graham, and today we are looking at lesson 21-1. We're going to be focusing on 45, 45, and 90-degree triangles. So go ahead and have out pages 291 through 294. Our learning targets for today are that we're going to describe the relationships among the side lengths of a 45, 45, and 90-degree triangles, and then we are going to apply relationships in special right triangles to solve problems. Let's go ahead and take a look at the problem below. It says the community hospital wants to make its rooms more cheerful. The hospital asks volunteers to sew quilts for patient rooms and to decorate the common areas. The Hoover High School Student Council wants to participate in the project. Mrs. Jones, a geometry teacher, decides to have her classes investigate the mathematical patterns found in quilts. Quilt blocks are often squares made up of smaller fabric pieces sewn together to create a pattern. There are many different quilt block designs. Often, these designs are named. The quilt block design, made up of 9 small squares called the friendship star, is shown below, right down here. We can also see a couple of other sample quilt block designs shown in the margin on the right. Let's go ahead and continue downward to see what we are going to be focused on and how we can relate this to a mathematical connection. The friendship star quilt block contains 5 small squares and 8 triangles. So if we can see within the picture, right, we know that there's 9 blocks. We can see that there are some small squares, and we can see this through 1, 2, 3, 4, 5 squares, and then we can see the 8 triangles. We have 1, 2, 3, 4, 5, 6, 7, 8. So that's how they divided up the 9 blocks. It says identify congruent figures in the quilt block and explain why they are congruent. So let's start talking about the small squares. What we can say for starters is that we know squares are congruent. So we're going to say squares are congruent. So that's kind of our this first identifying piece. Something else that we can see is that our triangles are congruent as well. And the reason we know this is because we can see that our diagonal cuts through and divides each of the squares into 2 triangles. So we're going to say the triangles are congruent since the diagonals in the squares divide them into 2 congruent triangles. Let's go on to part B, where it says classify the triangles in the quilt block by their angle measure. So what we're looking at is, let's say we're looking at this rectangle. We know that this diagonal divides it in half, so we are looking at this triangle right here. Well, let's start looking at just one of the angle measures here. We know if we showed this symbol in our triangle, we know that these are right triangles. So let's start off with that piece of information. So let's say that we know those are right triangles. Now, part C, if we move down a little bit, we can see it's asking us to classify the triangles in the quilt block by their side lengths. So again, let's look at this triangle. Think of what we know about the horizontal and vertical length that I have outlined here. Well, we know that since they are both the side lengths of a square, and a square's all of its sides have equal measure, we know each of those lengths is congruent to each other. So here we know 2 sides are going to be congruent to each other, so we know these have to be isosceles triangles. So all of them in our picture will be isosceles triangles. Now let's go down to part D. Actually, we can see that it's on the next page, but what I'm going to do for the sake of our question is I am going to copy and paste that question below since I have my figure here. So I went and copy and pasted the question below. So it says, what are the measures of the acute angles in each of the triangles? So looking at this, all right, let's draw kind of a sketch off to the side, let's try again, of our triangle where we know it's a right triangle. We know these sides are congruent to each other. Perfect, that's looking good. So think, what do we know about these acute angle measures? And I kind of gave you a hint with how I marked them. So think about, what do we know about them? So think about how all triangles have 180 degrees. And if we know that these two sides of our triangle are congruent, we technically know that these two angles are base angles, right? Our 90-degree angle is our vertex angle. We have our base angles. So I'm just going to remind us of, these are our base angles. And we know that they are going to be congruent to each other. So we have to think of, okay, you know, two angles plus 90 adds to 180. Well, that means it has to be 90 degrees split between the two angles. If we take 90 degrees and divide it by, we divide it by 2, that gives us 45. I was already starting to give you the answer. So we know that each of these angles is going to be 45 degrees. And this is because we know the diagonals. So the diagonals in a square bisect. Remember this from our quadrilaterals unit. They bisect opposite angles, right? So this means the 90-degree angles are cut in half. That's kind of just like a tidbit for you to remember off to the side. All right, nice job. Okay, so you're already on to the next page, so I'm going to go ahead and join you for question number 2. All right, so we are going to go ahead, zoom in, and start to look at question number 2. So it says the Hoover High Student Council decides to make friendship star quilts of various sizes with different sized quilt blocks. So even though we are watching this video and we aren't necessarily in class to talk together in groups, I'm going to be your partner as we work through on this. So it says, work with your group and use the Pythagorean theorem to find the exact values of the missing dimensions and ratios in the table below. So we know, with looking at our friendship star quilt, we know that there are 9 blocks. It's essentially a 3 by 3 block piece we're working with. So I'm drawing a sketch off to the side here, just so we can kind of visualize that and see what we're working with. I know it's not as exact, but work with me on this. We're gonna do the best we can with this sketch drawing. So we're gonna start going through and using this as kind of our visual. We're gonna see how we can fill in the table. So every single one of these is going to be 9 squares altogether. So let's say that we have 9 inches by 9 inches. So let's say we filled in that this length was 9 inches, as well as that length. I want you to figure out what is going to be the length of each triangle leg. So remember, visualizing our triangle leg is going to be these sides that I'm outlining. So I'm asking you, doesn't matter, how long is each triangle leg going to be? Well, I hope that you said 3 inches because, well, we technically don't have to label the 3 in there, but we want 3 inches because we have a 3, 3, and 3. All 3 of those 3's added together give us 9, so that's looking good. Now, here's what it wants us to do. It wants us to find the length of the hypotenuse. So this requires a little bit of math, all right? It requires a little bit of work from our end. So we might have to show some work off to the side. I'm going to show some on the right side over here. So I'm going to show you what I have. I'm going to put a little star to show that my work is going to be over here. So essentially, remember, this is a right triangle. Couldn't we use Pythagorean theorem to find that hypotenuse? Right, so we're essentially using a squared plus b squared equals c squared. So we're filling in the legs of 3 and 3, seeing how to get c squared. So that way we have 9 plus 9 equals c squared. We got 18 equals c squared, so we have the square root of 18 equals c. Remember, I do want you to put this in simplest form. So here's a note at the top. You want to make sure you have simplest, I got to spell that correctly, simplest form. That means we might need to, simplify a radical. So think of what perfect square number goes into the square root of 18. Well, remember, we can divide that up into the square root of 9 times the square root of 2. Essentially, the square root of 9 is 3. We can't take the square root of 2. So lo and behold, we're looking at 3 root 2. So that's telling us how long our hypotenuse is. It's 3 times root 2. Now, root 2 is a little bit more than 1. It's like 1.414, something along the lines of that. So we're saying that our hypotenuse is a little bit bigger than the leg. All right, so now we have to write a ratio to compare the hypotenuse to leg. So whenever we write a ratio, sometimes we can use it as, we can write two numbers and separate them with a colon. Sometimes we can write it as a fraction and see how we can reduce that. I'm going to go ahead and I'm going to show you in fraction format. So we're going to look at it in that way. We're going to put our hypotenuse on top and we're going to put the leg on the bottom when we compare it and then see if we can reduce our fraction. So on top we will have 3 halves. On the bottom we will have 3. When we reduce that, we end up with root 2. So that is what our ratio is. We're saying our hypotenuse is root 2 times as much as our leg, which makes sense because you have to multiply 3 times root 2 to get the length of the hypotenuse. So what we're going to now do is we're going to go through, try a couple of these out here and see if we can notice maybe any patterns that are occurring. So we don't necessarily have to, do the math and show all this work for every single one of these. All right, so here's what I'm going to have you do. Let's go ahead and see if we can start to notice a little bit of a pattern here and follow it up from the top, okay? So we have 15 by 15 inches now. So let's say we don't have 9 inches anymore. I'm going to kind of cross that out. Let's say we now have 15 inches. So what do you think will be the length of the triangle leg? That's right. It should be 5 inches. So we have 5, 10, 15 across. So now we have to go ahead and find the length of the hypotenuse. So again, we're going to have to use Pythagorean theorem. Let's do it off to the side again. So kind of over here. So let's do our 5 squared plus 5 squared equals c squared. We'll do a little bit of quick math. So we have 25 plus 25 equals c squared. We got 50 equals c squared. So that way we have the square root of 50 equals just c. Now, if we reduce that, right, we get the square root of 25 times the square root of 2. We can take the square root of 25, that's 5, and then we have root 2. So this is our length. So we have 5 root 2. So some of you might be starting to notice some patterns. Okay. So again, let's follow suit and put the ratio in. All right, the length of our hypotenuse is 5 root 2. Length of our one of our legs is 5. Hey, 5 root 2 over 5 is just going to be root 2. Again, I wonder if I'm starting to notice a pattern here. Okay. So now, here's what we're going to try to start to do. We're going to see if we notice a pattern of any kind. Now, I'm going to go ahead and start to say maybe what we're going to have is if we have a leg and we have a hypotenuse, we can notice that the same value will be involved in each. Like I have 3 here's and I have 5 here's. But with our hypotenuse, we'll be multiplying whatever that length of that triangle leg is by root 2. So maybe that's a pattern here. So let's say maybe we know the length of our leg is 1. We could then say maybe this will be 1 root 2, or we could just say root 2 since multiplying by 1 doesn't change the problem at all. Going to the next piece, maybe we could say 1.5 times root 2 as the length of our hypotenuse. Let's go to the next one. Maybe we could say it's 2 times root 2. So following this pattern, we can see what's happening. Now, this guy down here, we're going to come back to him. I'm going to work a little bit with you and show you what happens, but this follows the same pattern. So maybe we can fill in, hey, what is our leg going to be, right? So this last one, I think we can fill in what the leg will be. Let me go ahead and grab a different color. So yes, let's do orange. I think the length of our leg will be 6 because it follows the same pattern here that whatever number is in front will be the length of each of the 2 triangle legs. So now, we could start to set this up and do the ratios, but I think every single time you're going to notice that it's going to be root 2, right? So we could actually put root 2 and it'll continue all the way down. Every single one of these, even the special one at the end, will have a ratio of root 2 when we compare the hypotenuse to the leg. So now let's go ahead and figure out how big the quilt blocks are. What are the dimensions? So start thinking about this. We needed essentially 3 of these to get to 9. We needed 3 of these to get to 15. So think about, every time we're essentially multiplying by 3 to each of those lengths of the triangle legs because they represent the side of our square. So let's go ahead and fill in what we know. So we're going to take 1 times 3. So we'll get 3. So it'll be 3 inches by 3 inches. For our next one, we're going to take 1.5, multiply it by 3. I'll help you out with the math. It'll be 4.5. So we're going to have 4.5 inches times 4.5 inches. All right, next piece that we're looking at is 2. So we're going to have 2 times 3, so that'll be 6 inches times 6 inches. Almost the last one on there, looking at this, we can see we're going to take 6 times 3, so it'll be 18 inches by 18 inches. All right, and we can see, the biggest our quilt is means that the length of our legs and our hypotenuse is the biggest so far. So now let's look at this problem, right? This is kind of a doozy over here, right? How do we even approach it at all? How do we look at it knowing this relationship? We kind of have to think backwards. We have to think about maybe in regards to our ratio, right? We know this is still going to be root 2. So essentially what we're saying down here at the bottom is we could take 4 and we could divide it by something to get root 2. That's what we're looking for here with our question mark. 4 divided by something will give us root 2. This is kind of like a little bit like an algebraic problem, right? Where we're isolating one of our variables and solving for what we don't know. So maybe instead of a question mark, I'm going to erase that. And what we can do instead is maybe we could put x in that spot. So I'm going to put x in that spot. Now I'm going to figure out, how do I solve for x? How do I get x by itself? Well, maybe the first step would be to, remove x from the denominator. So maybe I can multiply both sides by x. And then I can write down what I have. I have 4 equals square root of 2 times x. And then how do I get x by itself? I divide by square root of 2. I know it's a little bit lighter to see the work, but I just wanted to change the pen color. So essentially we have 4 root 2 is equal to x. So that's what we're going to be filling in up here. We have 4 over root 2. Now, I'm really going to throw it back to you, right? Do you remember something called rationalizing the denominator from Algebra 1? Oh boy, well, what does that mean? That means, so I'm going to have another arrow that I'm essentially drawing to. That means we don't want to square root in the denominator. So what we actually have to do is multiply. I know, right? We have to multiply our numerator and denominator by root 2, because if we multiply the denominator by itself, root 2 times root 2, that'll be square root of 4, right? Square root of 4, but square root of 4 just changes to 2, so there's no more root there. Now on top, we just have 4 times root 2. That won't change anything, so we'll have 4 root 2 over 2. And then last but not least, remember, we can divide any terms that are outside of our radical, so 4 divided by 2 will be 2, so we have 2 root 2. Whew. So we did all that work to show that 4 divided by root 2 is equal to 2 root 2. So, cool thing to kind of look at. All right, a little bit of hard work, but guess what? Reviewing these basics that we learned in Algebra 1, it's going to come back in this unit. So if you are not familiar with rationalizing the denominator, and in fact, I am going to say that in the margin. This is rationalizing. So rationalizing the denominator. All right, so if you're not familiar with that, I would definitely check that out and see if you can refresh yourself on that topic. So we're almost there, almost done filling the table. Now that we know what these are, remember, we take these and multiply them by 3. Now remember, when I take this number and multiply it by 3, I just multiply the number outside, remember, outside of the root. So that will be 6 root 2. So we have 6 root 2 inches times 6 root 2 inches. Whew. Nice job. All right. So what was the purpose of doing all of this? Well, we're going to look at number 3 and see what patterns do we notice in the table. and number 2. So something that I really want to focus in on is the relationship between kind of our 2 middle columns. So I'm actually going to highlight that for us to look at. So I want you to compare these 2 middle columns and see if you can find some special relationship. So what do you notice? Well, you're going to notice that in order to get your hypotenuse, in the 3rd column, it's equal to your leg times the square root of 2. So that's a pretty cool pattern that we noticed. It worked every single time that we looked through that. Awesome. All right, let's look at number 4, but again, we're still building off the table. All right, so let's read the background. It says, suppose that you are only given the length of one leg of an isosceles right triangle. It says, write a verbal rule for finding the lengths of the other 2 sides. Well, wait a minute. We have a key word here, isosceles, right? If we have an isosceles triangle, we know that both of the legs have to be equal to each other, right? So what we'll say is the other leg is the same, right? It's congruent, is the same as the given leg, right? And instead of using Pythagorean theorem every single time, right? What we could do is we could say and the hypotenuse is leg times root 2. So that's our easy rule. So instead of having to do all of this work, right? We easily are going to see, hey, hypotenuse is leg times root 2. So now let's look at part B. Ooh, all right, here we go. It says, let L be the length of the leg in any isosceles right triangle. It says, use Pythagorean theorem to derive an algebraic rule for finding the length of the hypotenuse H in terms of L. So what we're saying is, okay, let's say we have L as our leg. We're going to see if we can find a rule using the Pythagorean theorem to identify H, our hypotenuse, okay? So let's say we have a picture, and I'm going to draw a picture over in the margin. So let's say we have our isosceles right triangle. Forgive me for the sketchiness of this picture. But we're saying that L, and I'm going to use a cursive L, represents the length of each of our legs. Now, yes, we're going to have H as the hypotenuse, but instead of having 2 variables, I'm going to try to write H in terms of L. So I'm going to try to rewrite this so we're only using the letter L. So going back to the Pythagorean theorem, remember that's, the 2 legs squared. So I'm going to say L squared and add it to L squared. We set it equal to H squared. So our goal here is to figure out how we can isolate H, right? Because instead of writing H, we want to write something else in its spot. So we know down here when we have like bases, we can combine them together. We can add them together. So I have 2L squared. That's going to be equal to H squared. So my last step of this would be to take the square root, right, to kind of cancel out that squaring, right, since they're inverses. So really the square root of 2L squared is equal to H. Now think about this. We have an L squared under the square root. Can't we break this up into square root of 2 times the square root of L squared, right? And then we can still see, wait a minute, the square and the square root cancel out there. Again, we're left with square root of 2 times L equals H. Couldn't I rewrite this as L times the square root of 2 equals H? Yeah, I could. That's definitely one way that we could look at this. So remember, what we're saying here is that our hypotenuse, just like before, is whatever our leg is times the square root of 2. But also something else that I want to point out as well. Also, we're going to see that let's say we wanted to figure out what the leg was, right? What would I have to do to isolate the leg? Well, I would have to divide by square root of 2. So maybe if we have our leg, right, we know that's just our hypotenuse divided by square root of 2. So let's say we knew the hypotenuse, didn't know the leg. Well, we could just take, our hypotenuse divided by square root of 2. Essentially, that's what we did up here, right? We had our hypotenuse, we divided by square root of 2, got the exact same thing. So these are good key notes right on over here. Definitely something you want to write down and keep in the back of your mind. Let's go ahead and turn to the next page where we're going to practice some examples in the margin and then the ones they give us in the textbook. All right, so we are on the next page. So let's zoom in to the margin over here. So I'm going to look at the margin. Now I'm going to go ahead and put some examples that we are going to do together. So you're going to want to pause the video right here so you can copy them down. So here's what we learned as a rule for 45, 45, 90-degree triangles. So we learned that if we have L set as the length of our legs, our hypotenuse will always be L, which is the length of our leg, times root 2. Now that we know this rule, let's go ahead and try the example that we have below. So we have a right triangle, and I'm also going to tell you that we have both sides, our legs are going to be congruent, just like in our picture above. So we want to try to figure out what x is. So looking at this, we know that the leg is equal to 3, right? So we know if we wanted to find our hypotenuse, right, we would just take the leg of 3 times root 2, right? So we know that x is equal to 3 root 2. I know, that one was a pretty easy one as well. So like I said, we just want to practice a couple of examples here. Let's go ahead and take a look at our next example below, where we're going to want to solve for x here. Ooh, okay, so looking at what we did before, right, we don't have a leg, so it's not going to be that simple, right? We kind of have to refer back to what we did before, right? So we realized that if we have our hypotenuse, so our hypotenuse is 10, in order to find the leg, we have to take the hypotenuse, 10, and divide it by root 2. Now remember, we have to rationalize the denominator. That means multiplying the top and bottom by root 2. If you're able to do that math in your head, right, we should get 10 root 2. And in the denominator, we should have the square root of 4, which is 2. We can reduce that, right, to 5 root 2. So that's what we're looking at for x, all right? So that's what x is going to be, 5 root 2. Let's go ahead and take a look at one more problem below. So let's scroll on down and see our problem. Whoa, all right, this is a little bit of a tricky one. Change the orientation, so figure out what we know. All right, something we know is that our leg, right, is 7 root 2. So in order to find the hypotenuse, right, we take root 12. We take our hypotenuse, and remember, we have to times it by root 2 to find out what that is. So take your leg of 7 root 12, times it by root 2. Now remember, this goes back to multiplying radical rules, right? So if we multiply numbers underneath a radical, right, we get the square root of 24. Now remember, we have to reduce this radical, right? So think of the biggest perfect square number that's going to divide into that. It's actually only going to be 4. So we have 7 times root 4 times root 6. Root 4 is just 2, so we have 7 times 2 times root 6. So that way we get 14 root 6. And that, my friends, is what we have for x now. Remember, all of these are units, so I could go ahead, add units here. I could add units there. I could add units here. It's representing a specific length, either a hypotenuse or our leg in these special 45, 45, 90-degree triangles. So now that I kind of walked you through some of those examples, right, we have our rule off to the side here. Let's go ahead and do the check your understanding here. So what I am going to go ahead and do is I want you to pause the video right here. I want you to use kind of the examples that we went through, and I want you to try numbers 5, 6, and 7 over here. So pause the video, go ahead and try 5, 6, and 7. Find the unknown length x. All right, let's go ahead and check our answers. I know number 7 was a little bit tough, but let's go ahead. So what I first started off doing was labeling leg and hypotenuse. Again, I know these are all 45, 45, 90-degree triangles, so I could use my information over here. If I know what the leg is, I could find my hypotenuse. But also something that I want us to add over there is, let's say we want to find out what the leg is, right? We know that the hypotenuse is equal to the leg times root 2. Remember, to find the leg, that's just our hypotenuse divided by root 2. So that's exactly what I used here. I simplified it, and I got 17 root 2 over 2. Can't simplify that anymore. For 6, again, labeled hypotenuse and leg. Use the simple formula where we took 4 root 5 times root 2. Can't simplify that anymore, so it's 4 root 10. Last but not least, number 7. Refresh of algebra, because we end up dividing by root 2. So if you have square root of 12 divided by square root of 2, we can actually divide those out because they're both under the radical. I can divide that to get square root of 6. So I have 5 square root of 6. Again, all of them are units because it's a certain length. So we are almost there. We are going to go ahead and go on to our last 2 problems. Yay! All right, here we go. So these are some critical thinking problems. All right, so let's look at number 8. It says, Ms. Jones designed a variation of the Friendship Star quilt block called the Twisted Star. Using the rules you derived in number 4, what are the dimensions of the smallest triangle on a 12-inch by 12-inch quilt block shown below? So something you might want to do is label, 12 inches by 12 inches. Same thing there. Perfect. So we're looking for the dimensions of the smallest triangle in this quilt below, and we have to explain how we found our answer. So pause the video here. I want you to kind of try it out on your own, and then we're going to come back together and talk about this. So for me, here's what I'm thinking. If the whole length is 12, then each of these blocks has to be a length of 3. Sorry, has to be a length of 4 inches each. Okay. So now we really got to think outside the box. Let's take a look at this square. So instead of looking at the whole square, maybe we could just think about this portion. Do you see how this is kind of divided in half? Let me show it with the highlighter. How this is divided in half. So that means we know that this length here is 2, and the same is going to happen with this length here because we can see that it's divided in half. So both of those tiny little triangles have legs of 2. So if we redrew it just a little bit bigger, it's a bad bright triangle. Let me try again. All right, so it'd be 2 inches and 2 inches. So it's asking us what are the dimensions of the smallest triangle. So we know that both legs, right? So we know both legs equal 2 inches. But we also have to say what the hypotenuse of that equals. So again, following our pattern from before, to find the hypotenuse, we take the leg times root 2. So it'll just be 2 root 2 inches. Now, we kind of talked through our explanation of how we found it. If you just show this work, that should be fine. So we don't have to explain since we kind of talked about it together. All right, cool. So it looks a little bit hard since it's kind of twisted, but it really isn't if you just think about it and break it down. All right, last problem, number 9, and then you are done for today. It says the perimeter of a square picture frame is 40 inches. So let's go ahead. Let's draw a picture of this bad boy. All right, let's use some blue. Let's get up here. All right, so we have a square picture frame. I know it's kind of more like a rectangle. Let's try to make it more of a square. There we go. Perfect. So if the perimeter is 40 inches, remember, perimeter is every single one of these added together. And remember, all these are congruent with each other. So each of these must be a side length of 10 centimeters. Okay, so not too bad. So it says find the length of a diagonal of the frame. So let's look at our diagonal of our frame. All right, wait a minute. Doesn't this look familiar? Like, doesn't this, I don't know, look like a 45, 45, 90 triangle, right? Where we have 10 centimeters on one side and 10 on the other. I think you can pause the video here. I think you can answer the question yourself. So go ahead, figure out what's a diagonal. Our diagonal, as you know, should be 10 root 2 centimeters. Woohoo! And we are all done for today. So nice job taking notes. Have a great rest of the day.